Beneath the ice of a moon orbiting Jupiter sits an ocean holding twice as much water as every ocean on Earth combined. And for 40 years, scientists believed we were close to reaching it. New data just proved them wrong. If you've ever heard that Europa is our best shot at finding alien life, you've heard half the story. The other half just got a lot more complicated, and it's costing NASA billions of dollars to find out why. Let's start with what Europa actually is, because most people picture it wrong. Europa is not a planet. It's one of Jupiter's moons, roughly the size of Earth's own moon, orbiting the largest planet in our solar system once every 3.5 days. From a distance, it looks almost featureless, a smooth, cracked, ivory-colored ball streaked with reddish-brown lines that crisscross the surface like scars. Those lines aren't decoration. They're some of the most important clues in modern planetary science. Back in the 1990s and early 2000s, NASA's Galileo spacecraft flew past Europa multiple times and picked up something strange. As Europa moved through Jupiter's powerful magnetic field, its response wasn't consistent with solid ice all the way through. It behaved like there was a layer underneath that could conduct electricity, and the best explanation for that is salty liquid water. A global ocean, sealed beneath the ice, kept liquid not by sunlight, which barely reaches this far out, but by the immense gravitational squeezing of Jupiter itself, flexing Europa's interior and generating heat through friction. That single discovery turned a frozen, forgettable moon into one of the highest priority targets in the search for life beyond Earth. Here's the number that should stop you. Scientists estimate Europa's hidden ocean could hold more than twice the volume of water in every ocean on Earth. Not close to double, more than double, an entire moon smaller than our own, wrapped around a global sea deeper and larger than anything on our planet, hidden under a shell of ice. So the obvious question became, how do we get to it? And how thick is that ice really? This is where the story turns into a decades-long scientific argument, and where the newest research just delivered a plot twist nobody wanted. For years, estimates of Europa's ice shell swung wildly, anywhere from as little as 3 kilometers thick to more than 30 kilometers thick. That's not a small margin of error. That's the difference between an ice layer you could theoretically drill through with future technology and one that rivals the deepest ice sheets on Earth, sealed shut for millions of years. Scientists studied the surface for hints. They found something called chaotic terrain, jumbled, broken regions of ice that look like a frozen lake that cracked, shifted, and refroze. To many researchers, chaotic terrain looked like evidence of a thin ice shell, one riddled with fractures deep enough to connect the icy surface directly to the liquid ocean below. If that were true, it would be extraordinary news. Fractures reaching the ocean could act like chemical highways, carrying oxygen and other surface compounds down into the water, potentially feeding microbial life the same way certain nutrients feed life in Earth's deep sea vents. That theory shaped mission planning, public expectations, and years of scientific debate. It's the version of Europa most documentaries still tell you about. Now here's the twist. In late 2025, a team of planetary scientists published new findings in the journal Nature Astronomy, using data collected by NASA's Juno spacecraft. Juno wasn't built to study Europa. It was designed to study Jupiter's deep atmosphere. But in September 2022, Juno flew past Europa at an altitude of about 360 kilometers, and its microwave radiometer instrument, a tool that can essentially see beneath a surface by reading temperature signatures at different depths, captured something nobody expected in this much detail. This instrument doesn't take pictures. It measures how heat radiates from beneath the ice at 6 different microwave frequencies, which lets scientists estimate what's happening kilometers below the surface without ever landing. The results: for a shell of relatively pure water ice, the data points to a thickness of roughly 29 kilometers, give or take about 10. That's not the thin, fractured shell many hoped for. That's a shell nearly 18 miles deep in places, thick enough to put Europa's ocean much further out of reach than the more optimistic estimates suggested. But the real gut punch isn't just the thickness. It's what the cracks turned out to actually be. The same study did find evidence of fractures, pores, and other disruptions in the ice. Proof that Europa's shell isn't one solid, boring slab. But according to the researchers' modeling, those cracks only extend down a few hundred meters. A few hundred meters, compared to an ice shell that may be nearly 30 kilometers thick. In other words, the cracks are real, but they're barely scratching the surface, literally. They're too shallow and too small to work as a significant pathway connecting the surface to the ocean below. The chemical highway many scientists hoped for looks less like a highway and more like a driveway that dead ends before it goes anywhere. Why does this matter so much? Because habitability isn't just about having liquid water. Water alone doesn't guarantee life. Life as we understand it needs a source of chemical energy, and one of the leading theories for Europa was that oxidants, oxygen-rich compounds created on the icy surface by radiation from Jupiter, could seep down through cracks and essentially feed any potential organisms in the ocean below, similar to how nutrients cycle through Earth's oceans. If the ice shell is thicker than expected and the fractures don't reach deep enough, that surface-to-ocean chemical delivery system may be far less effective than scientists hoped. The ocean could still be there. It could still be salty, dark, and vast. But whether it's a hospitable environment for life, or a sealed, isolated deep freeze with almost no chemical connection to the outside world, just became a much harder question to answer. This is the uncomfortable side of real science that documentaries rarely show you. Discoveries don't always confirm what we hoped for. Sometimes they complicate the story. And Europa's story just got more complicated. But here's why this isn't the end of the search. It's the reason two of the most expensive planetary missions in history are already on their way. NASA's Europa Clipper launched on October 14, 2024, lifting off aboard a SpaceX Falcon Heavy rocket from Kennedy Space Center in Florida. It is, by mass, the largest spacecraft NASA has ever built for a planetary mission. When its massive solar arrays are unfolded, it's longer than a basketball court, a size necessary because sunlight out at Jupiter is roughly 25 times weaker than it is here on Earth. The mission's total life cycle cost is estimated at around $5.2 billion, making it one of the most expensive robotic exploration missions ever funded. Europa Clipper isn't going to land. It isn't equipped to detect life directly. Its job is more fundamental than that, to fly past Europa dozens of times, on the order of roughly 50 close flybys, at altitudes ranging from thousands of kilometers down to as close as 25 kilometers above the surface, mapping the ice shell, measuring its thickness in far greater detail, and searching for any regions where the ice might genuinely be thin enough to matter. It's scheduled to reach Jupiter and begin its science campaign around 2030, after a journey of nearly 6 years and almost 2 billion miles. It won't be alone out there. The European Space Agency's JUICE mission, short for Jupiter Icy Moons Explorer, launched back in 2023 and is on a separate trajectory to arrive in the Jovian system roughly a year after Clipper, expected around 2031. JUICE will focus more heavily on Ganymede, another of Jupiter's icy moons, but it will also conduct its own flybys of Europa, adding a second, independent set of eyes and instruments studying the same fundamental question: what's really going on beneath that ice? Between these two missions, scientists are hoping to finally settle the decades-long uncertainty. Is the shell uniformly thick across the whole moon, or are there regions, maybe near those chaotic terrains, where it thins out dramatically? Are there other mechanisms besides deep cracks that could still connect the surface chemistry to the ocean, like slow convection, where warmer ice churns upward over long timescales and carries material with it? Scientists studying similar ice-ocean systems, including newer research modeling how ice shells interact with the oceans beneath them, have proposed that ice shell shape and structure can actually reveal information about ocean temperature and circulation from orbit, essentially doing oceanography without ever touching the water. If that approach works on Europa, Clipper's flybys could tell us not just how thick the ice is, but what kind of ocean is moving underneath it. So where does that leave us? somewhere between excitement and humility. The ocean is almost certainly real. The scale of it is almost certainly staggering. More water than every sea on Earth combined, sealed away in permanent darkness under a shell of ice that may be nearly 30 kilometers thick in places. That's not a small technical detail. That's a shell deeper than the deepest point in Earth's oceans, made entirely of ice, sitting on top of an alien sea we have never directly touched, sampled, or seen. And the newest evidence suggests that whatever connects that hidden ocean to the world above it is thinner, shallower, and far less generous than we assumed for decades. Humanity has sent spacecraft billions of miles, spent over $5 billion, and waited years for answers. And the honest answer right now is, it's more complicated than we thought, and we still don't fully know. That's not a failure. That's what real exploration looks like. The moons that seem the most promising are often the ones that make us work the hardest to understand them, and Europa has been humbling scientists for more than 40 years. What we do know is this: somewhere out past Mars, past the asteroid belt, orbiting the largest planet in our solar system, there is a moon smaller than our own, with an ocean bigger than every sea on Earth combined, hidden under miles of ice, kept liquid by gravity instead of sunlight, cracked on the surface but sealed at depth. And in less than 5 years, 2 spacecraft built by 2 different space agencies are going to fly past it and try to finally answer the question that's haunted planetary science for decades. Is there anything alive down there? If Europa's ocean turns out to be sealed off and isolated, does that make it less interesting to you, or more mysterious? Tell me what you think in the comments. If you want to see what Europa Clipper and Juice find when they arrive, follow this page so you don't miss it.